Hello everyone and welcome to Keeping Tabs on Chemistry. In this video we're going to be discussing gas stoichiometry. So, Avogadro's principle. This is the same Avogadro that came up with our value for 1 mole, 6.02 times 10 to the 23rd. He also dealt with certain characteristics of gases. So Avogadro's principle says that equal volumes of gases at the same temperature and pressure contain an equal number of particles. So what this means is that 1 mole of helium at 273 Kelvin in 1 atmosphere contains the exact same volume of 1 mole of, say, iodine at 273 Kelvin in 1 atmosphere. Now this is extremely significant because helium is much, much smaller than iodine. Helium has a molar mass of about 4, and iodine has a molar mass in the hundreds. So Avogadro identified the volume of 1 mole of any gas specifically at STP, that 273 Kelvin and 1 atmosphere. This is what we call molar volume. It's just like molar mass, but instead of dealing with the mass in 1 mole, we're talking about the volume that 1 mole of any gas occupies specifically at STP. So 1 mole of any gas at STP occupies 22.4 liters, and this is consistent regardless of the identity of the gas. So how is this possible? The size of the gas particles is so small relative to the amount of empty space that the difference between a small and a large gas particle does not significantly change the volume. So we end up registering 22.4 liters regardless of the size of those molecules just because of the vast amount of empty space. Now this is not true for liquids and for solids because they are condensed forms of matter where there's very little empty space relative to the number of particles. So this only applies to gases. Molar volume 1 mole at STP is 22.4 liters. Now what if I had 2 moles of gas at STP? Most of you guys can do this in your head. You would have 44.8 liters. What if I had half a mole of gas? Well, that would be 11.2 liters. This is the same type of molar conversion we've been doing all year. So what is the volume of 3.5 moles of gas at STP? Well, I would use dimensional analysis. With 3.5 moles, I know that 1 mole is equal to 22.4 liters, so I have the moles cancel, liters on top. I know that this is 78.4 liters. Now I could also say, what is the volume of 44 grams of O2 at STP? So now we're using molar volume as one of our conversion factors within a larger stoichiometry problem. And it works the same way that we did stoichiometry before, just instead of using molar mass, or instead of using Avogadro's number, or instead of using a molar ratio, now we're using molar volume. So from here I'm going from grams to moles and then to volume. So I'm going to need molar mass first and then molar volume. So starting with 44 grams of O2, the molar mass of oxygen is 32 grams per 1 mole, and 1 mole is 22.4 liters, specifically at STP. So this is 30.8 liters. So you might be wondering, what if I do if I'm not at STP? Well, if you're not at STP, you can do the stoichiometry as normal, and then you can use Charles' law, Boyle's law, or the combined gas law to go from STP to whatever conditions you are under. But that is all we are going to cover for now on gas stoichiometry. I'll see you next time.